While the U.S. Air Force is still grappling with engine issues for the F-35, China's stealth fighter jets have quietly reached a deployment rate 5 times that of the U.S. military. What industrial capabilities and strategic resolve lie behind this achievement? In early July 2025, news of the PLA's 2 major Air Force units upgrading to the J-20 shook the world. The J-10C fleet of a certain aviation brigade in the Southern Theater Command had been fully upgraded to the J-20, with the Northern Theater Command following suit to complete a similar scale upgrade. From decision-making to the deployment of combat-ready aircraft, the entire process took less than 6 months. This pace forced U.S. media outlet Military Observer to acknowledge China's expansion of stealth fighter jets has completely outpaced the U.S. military, with an efficient, mass-production deployment iteration chain accelerating at full speed, reshaping the aerial power dynamics in the Western Pacific. At the core of this pace is the strong production capacity and focus demonstrated by the Chengdu Aircraft Industry Group. With a reduction in new orders for the J-10C, Chengdu Aircraft Industry Group has been able to concentrate at least 2 to 4 modern pulsed production lines on J-20 production. Total production is expected to exceed 120 aircraft by 2025. Crucially, 100% of these aircraft are prioritized for the Chinese Air Force. In contrast, while Lockheed Martin's F-35 production line has an annual capacity of 110 to 150 aircraft, over 70% of this output must be allocated to numerous international allies, leaving the U.S. military with an actual annual delivery of only 24 to 48 aircraft. This means that in terms of annual deliveries of stealth fighters for domestic use, China holds an absolute advantage of nearly 5 times that of the U.S. military. The J-35, developed by Shenyang Aircraft Corporation, has also entered mass production, and the gap between China and the U.S. in terms of the number of new stealth fighters will continue to widen in the future. The rapid deployment of the J-20 is not only about increasing numbers, but also a strategically planned move. The selection of deployment locations is highly targeted. For example, it has recently been confirmed that a J-20 unit has been deployed at the Luliang base in Yunnan province. The strategic value of this base is prominent. To the east, it can quickly cover the Taiwan Strait region. To the southeast, it can effectively control the Bashi Strait, the mandatory passage for U.S. aircraft carrier strike groups rushing to the Taiwan Strait. To the south, its combat radius can extend to the strategic choke point of the Malacca Strait. Meanwhile, the J-20 brigade newly stationed at a base on Hainan Island forms a strategic double punch, with the Luliang base in the South China Sea direction. The J-20S deployed here, supported by early warning aircraft such as the KJ-500, have an operational range covering the entire central and northern South China Sea. Their operational radius of over 2,000 kilometers allows them to launch attacks outside the effective strike range of U.S. Navy F-35C carrier-based aircraft, putting the shorter-range F-35C at a disadvantage. As a result, all 5 theater commands of the People's Liberation Army now have at least 2 fully operational J-20 aviation brigades, with the Southern Theater Command, which directly faces the Taiwan Strait, and the South China Sea, reaching a scale of 3 brigades. The total number of operational stealth fighter jets in its fleet now exceeds the combined total of F-35s possessed by Japan and South Korea. The generational performance gap between the fighters is also widening. The J-20 has fully transitioned to the domestically produced WS-10C Taihong improved engine, significantly enhancing reliability and thrust. In contrast, the F-135 engine, the core powerplant of the U.S. F-35, has long been plagued by reliability issues such as turbine blade cracks and fuel system failures, severely impacting operational readiness. More critically, the potential for engine upgrades. China's specially developed WS-15 Mi engine for the J-20 has completed testing and entered mass production, with its military thrust of up to 18.5 tons granting the J-20 true supersonic cruise capability and enhanced energy maneuverability. Meanwhile, the U.S. Adaptive Engine Transition Program, aimed at providing the F-35 with next-generation power, has been cancelled due to technical challenges and cost overruns. This has completely closed the door on the F-35, obtaining significant thrust improvements or efficient supersonic cruise engines, locking its performance ceiling and leaving it increasingly at a disadvantage in the long-term competition with the continuously upgraded J-20. In the race for 6th-generation fighter jets, which will determine future air superiority, China has also demonstrated a leading edge. Currently, China has at least 2 6th-generation fighter jet prototypes, referred to by outsiders as the J-50 and J-36, undergoing intensive test flights, with the cumulative number of flights believed to have exceeded 200. Observations indicate that the aircraft's noses have generally eliminated traditional pitot tubes, strongly suggesting the application of advanced sensing technologies such as distributed optical aperture systems and laser radar speed measurement, representing a significant leap in situational awareness capabilities. In contrast, the manned fighter prototypes under the U.S. Air Force's next-generation air dominance program remain primarily in the conceptual design and subsystem testing phases, with the first flight still a long way off. More critically, the project has recently faced significant budget cuts, dropping from hundreds of millions of dollars to approximately $50 million, with progress nearly stalled, reflecting the dual fiscal and technological pressures the U.S. faces in maintaining air superiority. The core advantage of China's stealth fighter achieving production capacity dominance lies in three key factors. Full-chain industrial autonomy. The J-20 has achieved nearly 100% domestic production across the entire supply chain, from aircraft engines, active phased array radars, advanced composite materials, to flight control software and weapons systems. This completely avoids the risk of production halts due to reliance on foreign countries for critical materials or components, as seen with the F-35. Exceptional cost control and economies of scale. Efficient supply chain management, skilled labor, and manufacturing optimization have kept the unit cost of the J-20 at approximately $110 million, just one-third of the cost of the US F-22. Stable annual production volumes effectively spread out R&D costs, creating a virtuous cycle of mass production cost reduction expanded production, a model the US cannot replicate after shutting down the F-22 production line after only 187 units were produced. Rapid technological iteration and forward-looking deployment. The J-20 program demonstrates remarkable agility. Its avionics and mission system software reportedly adopt an agile development approach similar to the Internet, enabling high-frequency optimization. As the J-20's annual production stabilizes at 120 units, China has already set its sights on the distant future. At the MOV test site, the J-56th generation fighter prototype was observed conducting formation flight tests with multiple Attack 11 stealth drones, validating distributed sensor networks and coordinated strikes. At high-altitude airports, the J-36 prototype conducted high-angle stall maneuvers, equipped with ultra-long-range air-to-air missiles specifically designed to target high-value enemy assets such as early warning aircraft and refueling aircraft. This combination of the J-50 long-range penetration strike and J-36 Air Combat Specialization 6th-generation aircraft targets the weaknesses of the U.S. military's distributed warfare system, aiming to penetrate enemy air defense networks and precisely dismantle key nodes within a 2,000-kilometer range in the Western Pacific using a multi-layered fire network composed of stealth manned aircraft, unmanned aerial vehicles, and long-range missiles. The U.S. Air Force's current predicament is evident. The F-35 program is mired in reliability, maintainability, and the high costs of Block 4 upgrades. The GAD 6th generation fighter program, which holds the future, is severely delayed due to drastic budget cuts. Some U.S. military officials have even proposed radical yet unrealistic concepts, such as skipping the 6th generation aircraft and directly developing space-based aircraft, but the cost per launch could reach as high as $500 million, and the operational effectiveness remains questionable, reflecting the anxiety and confusion surrounding traditional air power development pathways. Looking back to the maiden flight of the J-20 in 2011, just 14 years later, China has transformed the global aerial power landscape with its industrial capability to produce over 120 stealth heavy fighters annually. From the powerful indigenous WS-15 engine to the routine patrols of J-20 formations over Hainan Island, China is driving change in the skies over the Western Pacific through the dual engines of mass production and disruptive innovation, rewriting the rules of the game.